Good morning, everyone. I realize I'm the last person before lunch, so I'm going to try to speed up. So today I will talk about mzTab for metabolomics and the next version of it that we are currently in the process of developing to support reporting of small molecule mass spectrometry results. First of all, let's start off with interoperability and reusability in research in general. So at this conference, we've heard a lot about AI already, and of course AI models already require a lot of structured data in the sense that the models can easily extract concepts and understand unambiguously what is being mentioned in there. So first of all, if we want to report results from mass spectrometry or basically any biological experiment, we have to stick to best practice guidelines, telling us how to do things, aid us as a decision guide for method selection for both experimental and computational methods, and also leading to a first step to ensure high quality of results and data in general. Then, of course, we need to stick to minimal reporting standards. So nobody wants to report everything about an experiment, and that's also often almost impossible because there are just too many different factors at play. But it should be clear what is the minimum amount of information that is required to be able to reproduce an experiment. This also helps both analytical and experimental reuse, but also computational reuse as a result of that. Last but not least, we need defined and well-structured and validatable formats that can be easily generated by tools and then also be easily digested by other tools, of course. But we shouldn't leave out the human in the factor as well, because humans still will want to be able to interpret data, but also inspect the data, and maybe also visualize it easily. So combining all of these aspects allows us to enable large-scale integration and combination of data, and that is also the basis for machine learning applications. The mzTab-M data format was originally developed in 2017-ish and published in 2019. It was a joint supported by the HUPO-PSI MS Standardization Initiative and the Metabolomics Standards Initiative, and it is a single file standard for small molecule mass spectrometry experimental results, supports quantitative and qualitative reporting of these results, and is available primarily in a tab-separated format that is easily openable with Excel, for example, but I would advise to not do that for more complex studies, or as a JSON representation. The format itself consists of 4 different sections, mainly the metadata level that describes your study variables, your assays, your mass spectrometry platform, for example, and other relevant metadata for your study. Then you have the summary level, which is a typical aggregated table of your quantified and identified metabolites across your different measurements with some additional metadata on top. So typically what you would submit at the supplementary material with your publication. Then these summary level info down to the MS feature and quantitation level, where you have the raw MS features that were being used to actually do the quantification and identification. And last but not least, on the last level, you have the evidence section that supports to report how you did the actual identification of your metabolites, for example, by linking to mass spectral library hits or other external resources. So mzTab for metabolomics tries to stick to minimal reporting standards and guidelines and tries to support these by different societies, for example, that have been defined. But the main design idea behind mzTab for metabolomics is that you can adapt it to your use cases. It has an extensible schema. There are some minimal requirements inside. A lot of additional information can be added. Our extension mechanism uses controlled vocabulary parameters. That is also at the heart of the format, using controlled vocabulary parameters to define distinct concepts in the file so that they are unambiguously identifiable, which also later allows you to integrate the data, for example, via ontologies into knowledge graphs, and then from there on into AI models, as we saw earlier. There are already reference implementations available for the 2.0 format in Java, R, and Python. We're also looking forward to other implementations if you want to support us there. But the interesting part of this talk is actually now coming. So we are currently in the process of rebooting the activities to define the update of mzTab-M 2.1. We recently met in Tübingen at the HUPO-PSI to discuss these and prioritize some of these actions. And one of the things we have been discussing is that we want to relax some of the requirements of the format Specifically, this was raised by the ex-CMS developers to also build up mzTab-M files incrementally, even though you might not have all of the information available at one point in time, which allows us to use this format basically throughout a workflow of different tools, adding information incrementally from identification, from feature grouping basically to identification to quantification and then final reporting. We're also working on updating the JSON representation. So we have a complete JSON schema defined for the format that allows us to also generate implementations in other languages quite easily. But we will also stick with the TSV format for the time being. Last but not least, we are also looking into expanding the possible representations into binary representations, because for larger studies we have found that access and reading of mzTab-M can be a bit difficult. So looking into SQL representations, Apache Arrow, or other possible formats for that. What we also want to do, since we are operating in the ecosystem of the HUPO-PSI and the Metabolomics Society and many other standard initiatives, is to integrate other formats like mzQC and STRF into the format to make it more modular, to allow also to leave out certain parts of the information in the file if it is referenceable and basically expressed in another file. We will also have a hackathon activity at the Elixir Biohackathon Europe in November around crosswalking and interoperability of mzTab-M and other formats in the MS realm. However, there's only virtual participation possible at the moment, but I would still invite you to join if you're interested. And we, of course, need your use cases and input to develop the format further and to adapt it. So if you're a tool developer, please get in contact. We need people who want to create mzTab-M, but also people who want to read it, for example. So looking at the future integration of mzTab-M, typically you can express a certain number of MS runs, for example, in one mzTab-M file. You can express studies, for example, by using multiple mzTab-M files. But of course, we also want to be able to somehow create mzTab-M. We want to be able to fill it and expand it to make it usable to a larger audience. So one possibility that we are thinking of at the moment is, for example, using the lipidomics reporting checklist or other similar metadata capturing frameworks and minimum information guidelines to provide a path to generate the metadata parts of mzTab-M, then having other tools that create the feature parts, for example, of mzTab-M representing the mass spectrometry data, and then cross-linking that to other tools and file formats from the HUPO-PSI infrastructure. Why do we want to do that? Basically, we can then use mzTab-M as a central integration file format between all of these different spheres and different tools and resources, and can also use it, for example, to gather all of this information together in one point at one location, and then use this information to create submission formats or submissions directly to the large data repositories like Metabolites or Metabolomics Workbench. We're actually currently already developing a prototype of mzTab-M to MTBLS mapping, so being able to directly create a metabolite submission from our mzTab-M file, together with MZML, of course, and other files if necessary. So with that, I'm at the end of my presentation. I thank you for your attention. I would like to also highlight all of the HUPO-PSI group members that have been contributing. There are many more, of course, not only in those groups that are listed here. If you're interested in joining the group activities around mzTab for Metabolomics, please join our mailing list. We have regular 2 weekly meetings. And we also have recently migrated our mzTab-M GitHub repository to its own location in the HUPO-PSI namespace. And with that, I'm happy to take any questions. Thanks.
Thank you, Nils. Questions?
Great to see this initiative. Do you have plan to develop some of the converter tool that can translate the mzTab to more like machine learning ready format?
Yeah, that would be great if you have someone who can provide that input. Of course, we're just a limited group of people, so we do this on our free time and on a voluntary basis. So anybody who can support this, for example, with lending us a PhD student for some time, who can be integrated then, of course, also in future publications, that would be great. By the way, I'm also recruiting a PhD position at the moment, so if you're interested in joining also towards this format development and future integration with the repositories, that's also a good opportunity.
All right. Thank you, Nils, as well as all of the other speakers. This concludes our morning session. So thanks, everyone.